If you use AI coding assistants for Salesforce development, you know the frustration. They write code based on general knowledge, but they often hallucinate or fail because they lack visibility into your custom objects, metadata, or specific org configuration. The Salesforce DX Model Context Protocol Server, or MCP server, solves this problem. MCP is an open-source standard that acts as a secure connector, linking your AI client directly to your live Salesforce metadata. Before we set this up, you need 3 things ready to go: a local installation of the Salesforce Command Line Interface, or CLI, an AI client like Cursor or Claude Desktop, and a target Salesforce org. This integration gives the AI direct access to your metadata, allowing it to verify object structures and field types before it writes a single line of code. Step 1 is authorization. The MCP server has no built-in authentication system. It relies entirely on your local Salesforce CLI credentials to access any org. Open your terminal and run the command sforg-login-web to authorize your org through the standard browser flow. Do not skip this step. Failing to authorize the CLI locally is the primary reason developers encounter 401 unauthorized connection errors when their AI tries to connect. Once your login succeeds, take note of the specific alias you assign to this org. You will need that exact alias for the configuration file in the next step. This local CLI login acts as your foundational security layer. It ensures the AI can only interact with orgs that you have explicitly authenticated. Next, we need to register the Salesforce DX server with your AI. To do this, locate your specific AI client's MCP configuration JSON file. JSON is a standard text-based format used for storing and transporting data. File paths change by client. For Claude, find Claude desktop config.json. For Cursor, edit mcp.json. Open it. In MCP servers, add a block named Salesforce DX. Set command to npx and args to @salesforce/mcp server. JSON syntax is strict. A missing comma breaks the configuration and prevents loading. This configuration file acts as your AI's core instruction manual, dictating exactly how it should discover and communicate with your local Salesforce environment. Even with the server registered, the AI is completely blocked from interacting with your authenticated orgs by default. We have to grant it access. To define these permissions, go back to your JSON arguments array and add the --orgs flag. This table compares your options: default target org, an exact alias, or allow all orgs. Do not use allow all orgs, as blanket access is a massive security risk. Instead, tie this to a safe sandbox environment by typing that exact alias right after the orgs flag. This scoping parameter restricts the AI's operations to the specified environment. It prevents accidental command execution or code deployments to your production instance. With your sandbox alias in place, save the completed JSON configuration file. Now you must completely quit and restart your AI application. Closing the window isn't enough. Fully terminate the app to force it to read the newly updated configuration on startup. Once the app reloads, open its tool registry interface, like the plug icon. You should now see the SFMCP server listed as active and loaded. If you expand that menu, you will see a list of specific Salesforce tools available for the AI to use. Seeing these tools confirms the setup works. Your AI has established a secure handshake with your local Salesforce environment and is ready to receive commands. Let's put this to work. We can now give the AI a complex natural language prompt. Query my account records and create a new Lightning Web component to display them. Now, the AI immediately begins executing SOQL queries against your live metadata to map the account object structure. SOQL, or Salesforce Object Query Language, is used to search and retrieve specific data from your Salesforce organization. The AI performs these retrieval steps automatically after receiving your prompt. Using that real-time context, it writes the code, tests it, and successfully deploys the requested Lightning Web component directly to your connected org. By leveraging the Salesforce DX MCP server and optionally connecting the available Heroku and MuleSoft servers, your AI now functions as a fully integrated, context-aware development partner.